Today we're going to talk about transformations of functions. Lesson 8-1, exploring f of x plus k. We're going to split this lesson into 4 separate sections. Questions 1 to 3, questions 4 to 6, questions 7 and 8, and then we'll finish out with 11 through 14. The equation of the graph of y equals x, or f of x equals x, are referred to as linear parent functions. The graph of f of x equals x is shown below. Math term. A parent function is the most basic function of a particular category or type. Complete the table for g of x equals x plus 5. We want to complete this column right here. If x is negative 2, I want to know what negative 2 plus 5 is. That would be 3. If x is negative 1, I want to know what negative 1 plus 5 is. That would be 4. If x is 0, I want to know what 0 plus 5 is. That would be 5. If x is 1, I want to know what 1 plus 5 is. That would make that 6. If x is 2, I want to know what 2 plus 5 is. That would be 7. If x is 3, I want to know what 3 plus 5 is. 8. Part 2. Make use of structure. How do the y values for the g of x compare to the y values of f of x? Make a conjecture about the graph of g of x. As you share your ideas with your group, be sure to use mathematical terms and academic vocabulary precisely. Make notes to help you remember the meaning of new words and how they can be used to describe mathematical concepts. So how does this column compare to this column? G of x values, I got negative 3, positive 2, negative 2, positive 3, negative 1, positive 4, 0, 5, 1, 6, 2, 7, 3, 8. So the g of x values are 5 greater than the f of x values. So what do we think the graph might look like? Well, if I graph this, negative 3 comma 2 would be like here. And this one would be here, and here, and here, and here, and here, and here. So this graph, the graph of g of x would be 5 units above the graph of f of x. Number 3, test your conjecture by using a graphing calculator to graph g of x equals x plus 5. Graph this on the grid in item 1. I'm going to go ahead and graph it on the grid. We've already got the ordered pairs. I got negative 3 comma 2. So negative 3 comma 2. I got negative 2 comma 3. -2, comma 3. -1, 4. 0, 5. 1, 6. 2, 7. 3, 8. And I'm going to connect those dots with a line as such. What is the y-intercept of the parent function of the original picture? What was the y-intercept? Y-intercept of the first function looks to be right there at 0, 0. Where is y-intercept of the new picture? Y-intercept is where it crosses the y-axis, so it's this point, which is 0, 5. What is the x-intercept of the parent function? And what is the 0 of the function f of x? Now, x-intercept is where does it cross the x-axis? So it's that of the parent function, so the original picture. That is also 0, 0. Off to the side, it does make a note that the x-coordinate of the x-intercept is called a 0 of the function. You will learn more about zeros of functions when we study quadratics later in the course. So my 0 is at 0. It's just the x value there. X-intercept of g of x. So where does my line cross the x-axis? That would be at -5, 0. What is the 0? Well, it is the value or the x-coordinate. So the x-coordinate of that ordered pair is -5. Lastly, revisit your original conjecture in item 2 and revise it if necessary. How does the graph of g of x differ from the graph of the parent function f of x equals x? It has moved my y-intercept went from being here to being here. So it has gone 1, 2, 3, 4, 5. It has shifted up or moved up 5 units. On to the wrap up of this section.